All right, awesome. Thanks, Alyssa. So our project's called the Shot Chain. And before we get started, we just want to thank Alyssa, Mike, and Carlene for all of your hard work and effort in putting together this conference. So it's been great to listen to the first couple of presentations so far, and we're looking forward to presenting some of our work here today as well. And this is our team here. So like Alyssa mentioned, we have three Montreal guys here in Tyrel, Stokes, and Mikael Nahabedian from McGill University, and Thibaud Châtel from Magnus Corsi, as well as myself, Brendan Kumagai from Toronto, and the Canadian Tire Sports Analytics team. And with that, I'll get started with the goal and scope of our project. So the goal of this project is to go beyond the traditional expected goals model, as shown on the left here by that blue arrow, to build out this entire chain of models here. This can range from anything like context models, like whether we see traffic or not, or whether there's a one-timer or not, to outcome models like whether a shot's blocked or it misses the net or we score, to models for stuff that occurs after the shot, like whether it's a whistle or a rebound, and if it is a rebound, who recovers it. And we want to use these to evaluate both shooter talent and the context surrounding a shot, and then apply this to women's hockey to analyze both women's hockey players and gameplay. And this work was largely based off of our Stathletes Big Data Cup work, where we built out a Markov decision process to simulate realistic offensive zone play sequences. And here we're basically just taking the shot component of that model, and we're applying it, and we're adapting it and applying it to women's hockey here with the NWHL and international women's hockey data from Stathletes. And we do run into a bit of an issue with this in terms of just a bit of a small sample size and getting our models to stabilize. So what we did to mitigate this was supplement the data with the Erie Otters Stathletes data as well, which we'll touch on a bit more in a moment. And all of these models we're using here are called logistic models. And basically with these, we have some sort of outcome, some sort of yes or no outcome that we want to analyze. So for example, if we're looking at expected goals, the question will be, did we score? And then it's either yes, we did score and we got 1 goal, or no, we didn't score and we got 0 goals. And we want to take this outcome and use it to predict the probability that we score, or the probability that we get a yes here in more general terms. And to do this, we need two things. The first are called covariates. This is just basically information about the shots. So this can be stuff like if there's traffic or not, and how long has it been since the last shot. And what's really cool about our model fitting method called INLA, or the integrated nested Laplace approximation, is that we can add in this spatial effect as well. And this is kind of like a continuous heat map that allows us to value the shot location and put that into the model. And in addition to that, we can also split this heat map into the different leagues and share information between leagues. And what this does is it allows us to solve our small sample size issue by sharing the information between the leagues and kind of mitigating any little oddities that pop up with the small sample size. And also with that also kind of maintains the structure, the kind of underlying structure of each league, and it allows it to kind of differentiate between each other. As you can kind of see here, the OHL one looks quite different from the NWHL one in terms of just the overall heat there. Then finally, with these covariates and the spatial effect, we can predict the outcome here, or the probability of scoring, which is 9% here, or 0.09 expected goals. And furthermore, with INLA, we can also not only predict just a point estimate of 9%, but also get a full out distribution to kind of quantify the uncertainty in our estimates and build a confidence band around our results, which you'll see later. And with these models, we build what are called above expected metrics. So basically, when we're talking about these, what we do is we take the outcome variable we're concerned with, and we tally up all of the yeses from it. Here for expected goals, that's just the total number of goals we score, which is 1 in this case. Then we take the total of all of the probabilities that we get a yes. So in this case, that's our total expected goals of 0.25. Then we subtract how many goals we actually score minus what we're expected to score, and that's 0.75 goals above expected. And sometimes we might divide this by the total games played or the total number of shots. It just depends on what point we're trying to portray with our analysis. And with that, I'll pass it over to Mick and Thibaud, who will talk a bit more about the models and metrics and applying them to women's hockey.
So the first thing we looked into was the presence of traffic, offensively and defensively. So the heat maps on the bottom right of the slide show when traffic happened based on where the shot is from. So it's all about point shots, as you could have guessed, but interestingly enough, the source of shot with traffic area is larger in the OHL as a comparison to women's hockey, even though in the international level it comes closer. The one thing that stood out is that some teams are very much involved or not involved in both sides of the ice. And it's a thought that many teams in hockey attack and defend following the same philosophy of the game. So you attack the way you think is the most dangerous in hockey, and you're going to defend against that same style of attack because you think that's the most dangerous one in hockey. So, and you can think of Montreal, the way they're playing this year and for a few seasons. But so seeing teams creating a lot of traffic offensively and defensively, like Minnesota or the Metropolitans, makes sense in a way.
So from a purely tactical standpoint, what stands out with Minnesota and makes it a good example for what Thibaud was talking about from an offensive standpoint is that they usually play with 2 or 3 players very low in the zone. So wherever a shot is basically taken from, there's usually going to be traffic around the net. Then in terms of the D-zone play, they play a looser D-zone structure, and that leads a bit more traffic than we expect, as you can see in the chart here. But since they have Amanda Leveille in nets, that kind of mitigates the risk of the shots going in because she's probably one of the best goaltenders in the world.
So the next thing we look into was the performance of player on shooting on net. So according to your time and space context, what's your expectation basically of hitting a target and what was the result in comparison? So looking at your top 10, you can see there is mainly wingers, and you can think of all those shots straight after zone entry, straight on the goalie's chest, easy, clear shot, straight on the net. On the bottom 10, you have a lot of defenders. And we just want to be clear, you compare to the expectation. So if you take a point shot with a lot of traffic, you're going to be compared to point shot with a lot of traffic. So being a defender does not penalize you from the start. So it's not that defenders necessarily shot less on net than forwards, but individually, it is more probable that some defenders have less shooting talent than forwards, and that's maybe why they became defenders in the first place. But going back to the top 10, something came out during our group discussion, and it was that hitting the net is not necessarily a link to goal scoring. And you can see on the list there, beside maybe Grant Mentis, you don't have your superstar forwards in women's hockey in that top 10 list. And that's something we saw in other research, and that, for instance, I saw personally in my research on Switzerland, is that your best goal scorers, the players that go above their expectation the most, they are all close to over the 90th percentile in shooting volume, and they are all below the 20th percentile in hitting the net. So volume shooting is way more important than hitting the net on a regular basis.
So once again, as we can look at the top 10 players in the list, we notice the name of Danny Cameronisi, who is a perfect example to illustrate the point that Thibaud is trying to make. Basically, what Danny Cameronisi usually does is that she comes into the zone with a controlled entry and decides to come down the wing to put a lot of shots on net. What happens through this high volume shooting is that as she puts more shots on net, some of these shots will basically yield an N+1 event that's either a juicy rebound or another miscellaneous event that is going to get converted into a high danger scoring chance, helping her team generate grade A chances and goals in that way. If we look at the bottom 10 players in this list, we actually noticed the name of Bridget Lacquette, who's well known for her big slap shot. Unfortunately, her big slap shot is not that accurate, but in order to improve her very strong and powerful slap shot in terms of accuracy, Brigitte Lacquette could work on two things. First, it would be to use her feet better to adjust her body as the one-timer pass is coming through. And then it would be to start her shooting motion in the air so as to come down and time her shot more on a more consistent basis in terms of the point of impact, so as to ensure a more accurate swing and a more accurate shot.
So next we'll look into rebound recoveries, and just to be clear, it's all about recoveries, not rebound creation from the shooters. So it's all about, once again, the time and space context where those recoveries are made. And here we have some pretty obvious results, honestly, that your top 10 offensively are mainly forwards, which makes sense. Those are the players close to the net. And your top 10 defensively are mainly defenders, which also makes sense. Expect for Madison Packer. But just here on the side note, we're working on a fairly small sample, and we can just imagine what's possible to do for a full season or multiple seasons of data on assessing that specific skill, and be able to trade or sign players with the real performance data in mind, and not just reputation for that area of the game, as it is most of the case right now.
So from a technical standpoint, recovering rebound is contingent on three things. So recovering rebounds is basically winning puck battles. And to win puck battles, the first thing that you need to do is to have a quick reaction time. If you have a quick reaction time, and looking at the list for both the O zone and the D zone players that are listed here, we can all agree that all these players have quick reaction times. But as you have that, you're able to get into the battle to recover the puck. Then once you're in the battle to recover the puck, the two things that you need to do to win the puck battle is first to initiate contact to get the upper hand in the battle right from the start. And once you have the upper hand, it's all about shielding the puck using your body to protect it by putting it between the opponent and the puck to confirm possession for your team and complete the recovery.
So finally, we looked into our expected goals modeling result through heat maps. So shot decision and X goal maps are nothing new to hockey, and I can see the results are nothing new either. The lower slot is the most dangerous area on ice, and that's true for any age of competition and for both women's and men's hockey. One very interesting thing here is that your X goal most dangerous area is wider in the OHL as a comparison. It goes from the net to the top of the circle, basically, when in women's hockey, it only goes up to the circle ears and stops there. But we can also see that women shoot more, as shown on the heat map at the top of the slide. So they shoot more and from farther away, which leads to a paradox where women shoot more than men, but men are more likely to score on shot than women. Why is that?
So basically, some might think that it's because of shooting talent, but the real answer to that question, or at least part of the answer to that question, is not shooting talent. It's actually the opposite of that. In women's hockey, it's all about goaltending talent. In women's hockey, we've had a myriad of trailblazers at the goaltending position, including Manon Réaume, who played a couple of games in the NHL, Taya Curry, who recently got drafted in the OHL by the Sarnia Sting, or Eve Gascon, who continues to play at a high level of men's hockey in Quebec with the Cégep Saint-Laurent Patriotes. And basically, what this means is that the talent level is so good at the goaltending position in women's hockey across the board that it makes it difficult for the forwards and the defenders to actually score a lot of goals on these very talented goaltenders.
So now I guess we want to talk a little bit about expanding expected goals. So the idea here is we want to do what's called just jamming models together, essentially. I want to kind of start us at a particular moment in time in a particular location where we have all of this kind of context. Maybe there's traffic, taking all of that kind of context of a shot. And now instead of just predicting directly whether or not we get a goal, we're going to predict first in order to be a goal, the shot must not be blocked. So we have a model which tells us what's the probability of this shot being blocked. And now, given that it is not blocked, in order to be a goal again, it needs to not miss the net. And we have another model which predicts, given that it was not blocked, what's the probability of it missing the net? And again, in order to score a goal, we need it to not be blocked and we need it to not miss the net. And so given those two things, we have our kind of a traditional expected goals model, which takes non-blocked, non-missed shots and figures out what the probability of them scoring is. And so the kind of interesting bit here is that by building all three models, we're able to basically value a larger range of shots and kind of put them on the same sort of probability scale. And because of some of the stuff that Brendan was talking about earlier, because of the way the Bayesian models are made, we're able, even when we jam these models together, we're still able to get proper uncertainty values for them. And so we might expect, and I'll talk a little bit about this later, when we have this kind of, we're able to value more shots, we might expect metrics based on this sort of thing to stabilize a little bit quicker. But also it's important to note that a little bit like we were talking about before, we can easily break out the components of this, and just kind of like what Mick and Thibaud were doing with certain specific components. When you have all three of the models, it gives us a lot of flexibility, and depending on the kind of questions we're trying to answer, we might use different parts of the components. But because of the framework, we can always jam them together and still get nice uncertainty properties. And then looking at this kind of graph, this is just based on sort of this combined expanded metric. We see a lot of the sort of suspects in terms of top shooting talent that end up coming to the top of the list, even in our small samples.
So looking at the shooting percentage above expected versus the shots on net above expected, we notice that one player stands out from the crowd. And it comes as no surprise that this player is once again Marie-Philippe Poulin. So by every metric in women's hockey that you can try to calculate, what usually happens is that Marie-Philippe Poulin stands out from the crowd. And what makes Marie-Philippe Poulin so special is her ability to step up her game when it counts the most. In terms of her shooting and her goal scoring abilities, that stems from the fact that she has a very efficient and consistent shooting mechanic, which allow her to basically be very consistent throughout games and even step up her game in important moments.
So I guess we kind of talked about some of the kind of possible applications of this. So we showed that we can look at any of these individual metrics, and we can kind of use them to give us some understanding of the leagues, of teams and players. And one of the cool things about these types of models is they do generate heat maps. And with more data, we could also look at heat maps at the team specific or the player specific level. We can build metrics of any one of those models or combinations of those models, which is going to allow us to take into account a lot more context. And specifically, we talked a little bit about this expanded expected goals model, which is going to allow us to value all kinds of different shots. And now, where does this leave us for what we're looking at for future? Well, of course, there's a lot more things to explore with this combination of models. A lot more insights we could get, especially looking at different data sets or adding data to this sort of thing. A little bit earlier, I was talking about this notion of stability. If we can value more shots and maybe metrics based on that kind of larger sample, we might expect those metrics to stabilize a little better. There's a really good paper that I think is sort of flown under the radar in sports analytics about metametrics by Franks et al. And basically what they say is that when you look at a metrics, two important things are stability and discrimination. And so discrimination is how much variation are we getting in a metric that is able to separate players? And stability is how much sort of, how little variation do we have within the same player. And so I've been working on extending this framework to be able to give us good estimates of how much variation, if we look at, just the traditional expected goals model versus the expanded goals metrical model, how much good variance reduction in terms of stability we're getting, and are we still able to maintain the kind of the good variance that is able to tell players apart, essentially. And then really the motivation partly for us here is that we want to be able to simulate plays and sequences more effectively. And so by breaking down the probability of a goal into these component parts, we're able to simulate probable sequence better. So for example, if a shot gets blocked, we would expect where the puck ends up next to be different than if a shot goes directly on net versus a shot being missed. And so really we're trying to put this into a broader framework where we want to simulate realistic sequences and we want to value those sequences more realistically. During our big data cup, we basically skipped the block and miss step, which left a lot of information on the table and possibly made our sequences less realistic.
All right, yeah, and like Tyrel was just mentioning with the big data cup, we built out simulations to kind of simulate offensive zone sequences. And as you can see down here with the little shot component there, that's what we were focusing on today. And like Tyrel mentioned, with the blocks and misses, we've been adding to that since then. And we wanted to leave things off with a bit of a teaser for what we've been working on over the past couple of months, which is expanding this framework from not just the shots or just the offensive zone, but to the entire ice by adding in the neutral zone and the D zone. And this is just kind of like a bit of a blueprint for what our framework looks like for how a play develops from whistle to whistle, starting with like the face off, and then you can maybe recover it off the draw, make a pass, enter the zone, get a shot, and we get a whistle, right? So something like that, and doing simulations like that. And if you find this interesting, then we do have, or you can check out our big data cup work. We did have an article posted on Hockey Graphs earlier this week about that work. And we're going to have a follow-up one in a week or two, just applying that model. And yeah, hopefully in the future at some point, we'll have another article out with just this whole framework here to talk about some more and kind of expand upon our work that we did at the Big Data Cup there and apply it to the entire ice. And yeah, so that's our presentation today. So thanks everyone so much for listening. We had a really great time building this project and presenting it here, and we're looking forward to hearing from everyone else the rest of the day.
Thank you so much, boys. I just thank you for making me have to mentally rewrite my entire presentation that I'm giving in 3 hours in my head. That's great. Really looking forward to fitting that into my day somewhere. But like, your work's always phenomenal and I love it so much. A couple of questions from the chat. One person asked, what's the advice about You're going to say it the French way and I'm going to sound like a fool. Slap shot based on similar adjustments in the OHL data, or is that an eye test thing?
Yeah, that's more of an eye test thing where we would be looking at her shooting mechanic and her shooting motion. And the thing about Lacquette is that she has a pretty powerful slap shot as she brings her stick down with a lot of velocity, but making it more consistent and having a more consistent timing on her point of impact will basically allow her to be more accurate.
Another question, given the conclusion that women's games have a higher shot volume, and then also Nyan's conclusion in one of his articles, research things, that women pass more, does this mean that we can statistically say that the pacing is faster in the women's game?
I don't know the answer for sure, but that's definitely the kinds of stuff that, in other sports, when you're looking at making sort of pace statistics, you would definitely be looking at volume of key stats, and if I was to build a hockey pace metric, almost certainly the backbone would be shots and passes, and yeah, combining those two things, that does make a lot of sense to me. I can't say for sure, but that seems like a very fruitful avenue to look at.
Also, and I would add to that. Oh, sorry, I would add to that as well. Yeah, just with men's hockey as well, we do have hitting as well. So that might kind of like make things a bit more chaotic and kind of break up the play a bit more. Whereas in women's hockey, there's kind of not as many avenues to cause like different types of obstruction or break up the play.